My name is Johan Letters and I lead the security architect team at Sophos Global Sales Engineering. In today's session, I'd like to talk to you about our security solutions for the public cloud and how they can help protect your customers' cloud deployments. So let's start by talking about what we at Sophos mean when we're talking about public cloud. So we all have a common understanding of what we mean by that term moving forward and throughout this presentation. And in the process, let's also look at how we got here by examining the evolutions from traditional on-premise infrastructure to modern-day IT landscapes. Starting with on-premise networking. This is the model we should all be familiar with, where everything is physical in an office or data center owned by the customer, and the network segmentation as well as user segmentation is handled by the customer infrastructure through switches, firewalls, etc. From there, we gradually moved into co-location, which has now rebranded itself as private cloud, where you basically take your infrastructure and outsource some aspects of the physical operation of it to a third party to enable the benefits of leveraging economies of scale for your environment. Essentially, you're still operating the same network equipment, firewalls, etc., but now the physical requirements such as power and physical security are handled by the third party, and all you need to do is hook up your offices to that co-location environment through a private WAN link like MPLS or direct fiber so that you can enjoy these services. Now, once you have made that particular transition, the next one seems very logical, the move to the public cloud proper, where you are, at least in the case of IaaS or infrastructure as a service, outsourcing not just the physical connectivity of your servers, but the actual servers themselves as well. This further enables economies of scale and reduces hardware acquisition and management overhead from a customer perspective, since they can just ask Amazon or Microsoft to create the desired machines for them. In effect, throughout this entire evolution we've seen so far, we have leveraged growing economies of scale to move from physical servers to a model where the server that runs the actual service that you're using is commoditized in favor of said services. And in that process, we've done away with things like depreciation of assets, at least from a customer perspective, as you're now essentially renting your infrastructure. Or as an even more apt analogy, you're basically just consuming it the same way that you would consume a phone plan. And an even more poignant example of this is the existence of PaaS, or Platform as a Service. In this model, you go one step further than the aforementioned IaaS model, and you now simply ask the cloud provider to run the environment you need directly on the platform instead of first creating the virtual servers to run that service like you would in an IaaS scenario. This, in particular, has gotten quite popular since the beginning of this year, as it has enabled people to work from home by consuming virtual desktops as a service on these platforms, for example. This model also does away with a lot of the planning and provisioning overhead you'd otherwise need to take into account even if you were running on an IaaS model. And of course, the final step in this evolution is to transition away from even running a dedicated environment to begin with. You simply ask the cloud provider to run the service you need and have them take care of everything else. This model is known as Software as a Service, or SaaS for short, and it represents the logical end of the trend we've just discussed. You don't own anything anymore, and the platform simply provides the service you need. Sort of like how Netflix or Spotify work. All you care about is the movie or album that you wish to consume, and you leave all the details up to those platforms to make sure that you get the content delivered to you when you need it. And we, at Sophos, even offer a service through that SaaS model that you should all be rather familiar with, Sophos Central. In Sophos Central's case, instead of having to set up management and logging for your Sophos components, we simply provide it to you as a service, completely freeing you as the customer from any responsibility to build and maintain supporting infrastructure to manage your security estate. And of course, no discussion of SaaS can be complete without mentioning the titans of this model, Salesforce and Office 365, or O365 as Microsoft has recently redubbed it, both offering critical business tools without requiring the customer to worry about any backend infrastructure, patching, management, or whatever kind of other overhead. Anyway, coming back to my earlier point, for us, Sophos, when we're talking about public cloud security, we're mostly talking about the IaaS and PaaS models, the right-hand side of this diagram. We do offer some services for SaaS, and I'll get back to those later, but given that most companies are struggling with the security of their IaaS and PaaS deployed services, it makes sense for us as a company to focus on these models and talk about how we can help protect AWS, Azure, and GCP environments. Before doing that, though, it pays to know what motivates companies to move to the public cloud to begin with. There are obviously several different reasons, but the bulk of them fall into a combination of the following factors. One, it helps reduce capital expenditure in favor of operational expenditure, or to put it more simply, you can trade your capital expenditure for additional operational expenditure, reducing the risks traditionally associated with buying a bunch of hardware, such as depreciation and investment, and it allows companies to pay just for what they need at any given point in time. Another big reason is that public cloud infrastructure enables companies to automatically respond to increases in infrastructure demand without having to invest in additional overhead resources. This then enables companies to also be more agile and reduce the time to market by removing a lot of the traditional hardware constraints. A good example of this is when a company suddenly needs to accommodate new customers on another continent. Because cloud deployments can easily be replicated to other regions in the world, this can be done in minutes or even in some cases completely automatically, versus the traditional model where you would have to buy hardware, ship it there, hire someone to set it up, and then connect all these things before you can even start running your environment. And if we have to summarize it, ultimately, what cloud enables is companies to provision new environments in minutes versus days and weeks at a cost that is relevant to just the things that they're running at that point in time without having to worry about anything beyond what they are currently consuming. And it's clear that this model has become very popular. Earlier this year, Microsoft saw an explosion in users on their platform, even to the point of them having to reduce some of their free tier usage in response just to cope with the additional demand. Now, obviously, that's a little bit cheating because that is probably also at least in part, a result of the pandemic. If we look at, for example, the numbers that Zoom was pulling in at the start of this year, you can see a similar spike. But it does show one of the public cloud's major strengths, the ability for companies to immediately adapt to challenges and changes in the market. Another important thing to keep in mind throughout all of what we're going to be talking about is that the public cloud customer is not a homogeneous entity. They're not identical. Beyond different motivators, there's also a large distinction between companies that were born in the cloud and companies that migrated there. Born in the cloud obviously referring to companies that have had the advantage of being able to build out their infrastructure on public cloud platforms from the start, versus companies that have been around for a lot longer and have had to build their infrastructure on-premise and now need to move it to the cloud. Especially that latter customer profile is the one that will be struggling with migrating to the cloud, as they will have to overcome not just the challenges on the right-hand side of the slide, but also the things in the left-hand column. They've had their IT systems around for upwards of 10, 20, or even 30 years, and as such, they have a lot of things to take into consideration and account for when moving to a public cloud platform. In a lot of cases, for example, their current solutions weren't built to account for dynamic scaling, or even a non-physical infrastructure. And to make it even worse, a very large amount of these cases, in fact, in a lot of them, they may well be outside of software vendor support, either because they just stopped patching at a certain point in time, or because the vendor themselves folded years ago and no updates or support are even still available. And as a result, these companies will run into security challenges. If you are currently set up with a single point of entry through a firewall, for example, moving to the cloud means that you'll need to redesign for an environment where public cloud accessibility is a given, where anybody who has access to an internet connection will be able to access your environment in the case where you make a mistake or an erroneous configuration, because that no longer just affects your own users. It potentially opens up your environment to those outside attackers or any kind of outside influence. But that, luckily, to some degree, is not unique to companies moving to the cloud. Even those that are born in the cloud struggle with the challenge of achieving visibility and maintaining insight into their operations in the cloud. This is also reflected in compliance requirements. In the past, these standards were designed for an on-premise world in which manual compliance auditing was the standard. You just needed to make sure that everything looked good every 6 months or so when the auditors came by, and you were good to go. But in an environment as dynamic and as public as the cloud, that doesn't fly. A perfectly secure, certifiable environment can be compromised the next minute if somebody makes a smaller mistake as a typo somewhere. So compliance needs to be continuous to account for this. And to exacerbate these problems, attackers know this. They are smart and they recognize the exact challenges that I mentioned. They also know that there's a lot of noise that they can potentially hide in along with that complexity. So they will leverage that to their advantage to make sure that they can go undetected for longer by obfuscating their attacks through these particular weaknesses. This is also why cloud providers operate within what they call a shared responsibility or shared security model. The reason here being obvious. Cloud providers can only account for the things that are within their control. And they will absolutely strive to operate a secure cloud platform. They take full responsibility for items such as physical asset security, being data centers, backup power, etc., as well as things like customer separation, storage and network availability, points of presence, and all the things that you would associate with a cloud infrastructure. Where that responsibility becomes shared, though, is in the things where customers take part of the responsibility away from the cloud provider, essentially in the things that they move onto said platforms. The providers will normally provide tools to secure access and such, but it's up to the customer to use those tools correctly in these cases. A secure cloud application that allows anyone to have access is, after all, a valid configuration, but perhaps not as secure as the one that you would like to have, because it might enable unintended access from public internet to those company resources. And that's what's really at the heart of these models. Cloud providers aren't all-knowing. They rely on customers to tell them what needs to be protected and to what standard, who should have access, all the major questions that go into securing an asset. In fact, when it comes to this, most providers even recommend extending their platform services with third-party solutions to address the things that their tools do not cover, such as additional firewalling and IPS, endpoint protection, and much, much more. You know, the stuff that we're all pretty much familiar with from the on-premise world. This becomes even more clear when we break the responsibilities in the model down into the layers that you see on the screen now. You can probably already start to guess where some of your favorite Sophos solutions will fit into this model. And that's exactly what we're going to do here. So let's start at the bottom layer of your responsibilities, the cloud foundations. This is that gray area that I talked about, where a cloud provider has deemed it sensible to deploy additional security controls, but leaves it up to the customer to deploy them properly. And this, perhaps unsurprisingly, is a big deal, as misconfigurations such as leaving ports open, leaving cloud storage in public mode, not encrypting data, or creating overprivileged IAM roles were found to be exploited in 66% of cloud security incidents we saw in a recent survey. This is the reason we added Cloud Optics to our portfolio, because Cloud Optics was designed from the ground up to address exactly these challenges through what we like to call the 3 pillars. Starting with visibility. You can only protect what you can detect. So showing companies what their threat surface looks like by adding insight through smart visualizations helps them to build a good basis to start designing their security from. Next, once you know what your security posture should look like in the cloud, and now that you have good visibility, you can start to automatically detect deviations from this desired posture. So you can then respond, because obviously we would want to fix any potential security issues that we have in our posture as efficiently and effectively as possible so that they can be remediated as quickly as they are found. Cloud Optics achieves this through several key features, starting with asset management. By having a consistent inventory of all cloud assets on multiple cloud platforms and in multiple accounts, it massively improves the visibility into these environments. From there, it uses visualizations and contextualization to add insight, for example by drawing a real-time map of an environment's network layout, or by visualizing IAM permission structures and analyzing account usage versus account permissions to see if users or roles are over-provisioned in terms of permissions to the tasks that they're actually trying to do. From there, that data gets fed into our policy engine to continuously check against compliance standards for the environment. Note that we use the word compliance loosely here because it doesn't just describe industry standards like your favorite acronym soups, the PCI DSSs, GDPRs, ISO 27001s, etc., but also covers custom compliancy templates that you can design to match your specific security posture. Because every company's security requirements are different, every company's desires for security are different as well. So that means that when we're doing automated checking of these types of environments, we want to make sure that we account for that. Once you have then established that something deviates from the desired state, you can now start to fix it. We can do this through our smart alerting feature, which provides contextual alerts that include both remediation as well as the cause for flagging the alert in the first place, along with an ingenious functionality that groups all affected resources together under the same issue so that you do not get inundated with alerts, thereby essentially turning policy violations into work statements that describe exactly what's wrong, how to fix it, and what assets are affected. And that's also where our integrations with ticketing systems and alerting systems like Jira, PagerDuty, and ServiceNow come in. Optics can automatically export these alerts and remediation instructions into the platforms that your teams are working with, so that when they get a ticket, they will know exactly what to do and how to progress. On top of that, Cloud Optics integrates with solutions like Slack and Teams for additional alerting, Splunk for data export, and even AWS platform security features like GuardDuty for additional input on threats. It also offers API access to many of these features, so customers can export data or upload their own data to run scans on demand against either their environments or their templates. And that brings me to the last item on this slide, infrastructure as code scanning. Cloud Optics can scan templates for CloudFormation, Azure RM, Terraform, and Ansible to detect potential posture issues before they ever go live in the first place, allowing customers to stay ahead of the security curve and remediate those issues before they ever became exploitable, effectively turning a customer's DevOps into DevSecOps without having to first send an entire team away on a training or hold up DevOps processes with manual compliance reviews. Now that all sounds great, but let's take a look at what this looks like in a live environment. As you can see, I've just signed into Central, and I'll jump from here into my Cloud Optics console, which will then take me to the Cloud Optics dashboard. This dashboard immediately shows us all the important things I might want to spend some time on as an administrator of this environment. For example, at the top of this, I have a nice color-coded row of alerts, from critical to low, telling me whether I need to drop everything and immediately go and fix something, or if it's not a critical alert, simply log it as an issue, create a ticket, and let the normal IT processes in my organization handle the remediation and cleanup of this item. Below there, we see the feature highlights, short videos of new features recently added to Cloud Optics that I might want to go and check out. Next, in the top right corner, we have this big compliance meter that shows us at-a-glance information and status about how compliant we are and how many of the checks in our policies we're currently passing and failing. And here at the bottom, we have a nice overview of all the changes that recently took place in my environments that I may want to spend some time on investigating. From that perspective, our ability to flip this high-risk changes toggle is very helpful, as it filters out any events not classified as high risk by our AI, making sure that I can spend time investigating changes that are likely actually affecting my security posture, instead of sifting through endless amounts of events that I then need to correlate manually. When we click on any of the alerts on the dashboard, we immediately jump into our alert view. And from here, we can examine those alerts in more detail, filtered by category. By default, the product displays a week's worth of events, but this can be changed if desired. If I click all, for example, I also get some nice critical events to look at, such as this SSH port with unrestricted access. Then, when I click on the alert, it shows me what we just talked about. A nice description in readable English of what's wrong, followed by the remediation steps with recommendations on how to fix these issues as provided by the platform provider, complete with a link to said platform provider's documentation on how exactly to proceed. Below that, I can see when we last saw this issue live, followed by the list of affected resources tracked on first seen. Now we do this for two main reasons. The primary being that this reduces the number of total alerts through smart grouping, as I talked about before. And the other being that this provides a built-in mechanism for setting the priority of the remediation actions to be undertaken. Something sitting in your account for weeks with a security issue is likely a more pressing problem to resolve than something that just went live a couple of seconds ago. Another interesting thing to point out here is this last modified by field, as this helps keep track of who may have introduced this particular security issue into the environment. Then, at the top right corner, we have some additional options, like creating a ticket in the aforementioned services, or suppressing the alert, either for all tracked items or individual issues to reduce false positive alert noise, or even starting off automatic remediation through our guardrails functionality. By working through these alerts, customers can not just gain better visibility into their security posture, that is to say, their exposed services and configurations, but also actively work on improving said postures. Another interesting thing to look at here are the reports. This is where you find the full results of the policies you are benchmarking your environment against. So, if you want to know exactly which checks in which policy or compliance standard your environment passes and which ones it fails, here's where you'd find that information. For example, this particular environment, PESC, failed 39 out of the 80 security checks in the ISO 27001 compliance standard. That's not a great result. So let's click on this report to open it and examine in a bit more detail which checks have failed. Here you can see that we passed all the checks in Article 8, but we failed 13 of the checks in Article 9. If we then click on this, it will show us in detail which items in the standard we are failing. For example, we can see here that we're failing the check to ensure that no service accounts have administrative access. This is of course a really bad idea and something we should remediate immediately. Luckily for us, Cloud Optics lists all of the offending assets under the affected resources, so that should help our operations team address this issue quickly. And this is true for all the tests in this particular policy. We can drill down into all of these and determine why the test has failed. So by now I've talked a lot about policies. So next, let's jump into the policy section and examine how these work. As you can see, we ship a large number of industry standard compliance policies with the product, and these can be used to establish baseline compliance with the standards relevant to the customer's environment. Interesting to note here though is that Cloud Optics also has the ability to either define your own policies or customize existing ones, and they will be listed in the custom policies section. All you need to do is click either the Customize button or the Create Custom Policy button at the top to start creating your own policies from scratch. From here, let's dive into visibility features by looking at network visualizations. This feature creates real-time maps of the connected environments, enabling administrators to get a better understanding of how VPCs and the resources in them communicate with each other and the internet. You can switch from capture traffic view to a security group view, so you can immediately benchmark your capture traffic versus your designed allowed traffic, enabling you to refine your policies as needed when you see certain types of allowed traffic that may not be used. And as you can see, Cloud Optics will automatically highlight the traffic relevant to each resource by clicking on said resource. This then is, as I said earlier, a great way to easily determine if traffic is flowing as intended and if there's anything out of the ordinary by simply clicking through this interactive map. And yes, in case you're wondering, we can also support this for Azure and GCP. Simply change the environment type and Cloud Optics will display relevant topology maps using the platform's preferred iconography for all accounts on that particular platform. In this example, we jumped into Azure to look at an XG firewall to see how traffic from the internet is flowing to that XG and then from that XG onto the internal machines. Another interesting visualization is the IAM visualizer for AWS that allows you to see all your IAM objects and their relationships. Whether it's users, groups, or roles, the visualization can show how they are connected and how access privileges for any given object were assigned. For example, we can see that this dev user got access through the highlighted group to these services. And if we click on Luca, we can see that he has access to certain services both through the SC group as well as directly assigned privileges, which by the way are a big no-go in AWS's best practices. This also ties into our overprivilege detection feature, which maps IAM privileges onto CloudTrail data to show which users have more privileges than they actually use. For example, if we click on Sasha, we can see that he has access to 6 services in the right-hand menu, but he uses none of the privileges assigned to him as he hasn't logged into any of these assigned services in the last 12 months. And of course, we can do this for any user in the diagram, simply by clicking on them. Now, the next thing I want to talk about in this live demo is the Discover section, where we help increase visibility in customer environments by building a consistent inventory of items in the connected accounts. For example, we can see here how many network security groups we have or firewall rules in GCP and how many VPCs we have. As you may have noticed, we use color coding in the inventory as well. So if we see any configuration that may indicate a risk to the customer security posture, we highlight it either red or orange depending on the severity. In this example, our storage here has 7 public-facing storage accounts in Azure. And that, if we look at our IAM inventory, we see that we have a bunch of users who do not have multi-factor authentication enabled. And when you click on any of these items, it takes you into the relevant submenu, where in this case, we can see exactly which users don't have MFA enabled, as well as other details about their accounts, such as how overprivileged they are. Another interesting thing to highlight in the Discover section is our Spend Monitor. This feature allows customers to get a nice consolidated view of their spend over multiple accounts and platforms in a single view, complete with trend analysis. We can even use this data in the aforementioned policies to trigger alerting and reporting events when spend reaches certain thresholds, certain configurable thresholds. And the final thing I want to touch on is how a customer would set all of this up, as that process is quite easy. You simply go to the environments, click Add New Environment, then select, for example, Azure, and Cloud Optics will show us all the required steps to onboard that environment into Cloud Optics. Now, generally, these steps boil down to copy step 1, go to Cloud Shell, run step 1, repeat for step 2, repeat for step 3, etc., etc. And that is pretty much it. In about 5 minutes from running the script, Cloud Optics will have added the environment and will start providing relevant data for your customer to look at in the inventory we just talked about. And in case your customer wants to onboard even quicker, we offer quick start deployments for AWS, for example, that a customer can kick off with a single click in the Cloud Optics interface. And even for non-cloud services like native Kubernetes clusters, we simply provide the steps to follow, and Cloud Optics will do the rest. It's really that simple, nothing complicated about it. And the best part in all of this is that Cloud Optics does all its work in read-only mode. And that is just about it for the demo. So let's jump back into our slides and talk about the one last thing I didn't get to show you in the interface, and that's our AI alerts. Cloud Optics, as mentioned, does a continuous baseline assessment of the customer environment, and as such, knows when it sees user or traffic behavior that deviates from the norm. This enables us to detect possible indicators of compromise, such as an account signing in from different locations at the same time or within unreasonably short timeframes. This enables administrators and security teams to get alerted of suspicious activity that may warrant further investigation. Let's wrap up Cloud Optics by talking about licensing quickly, as we've recently simplified our model. Cloud Optics now allows for an unlimited number of accounts and an unlimited account number of users, regardless of the number of licensed assets. All license sizes include constant monitoring, and the minimum asset amount has been reduced to 25. And for those of you wondering what we now classify as an asset, it's pretty much anything that computes or databases. Everything else is considered fair game from a license perspective. So a customer with several hundreds of S3 buckets but only 50 EC2 instances would only be required to license 50 assets. And speaking of things that we've recently introduced, we recently introduced Sophos Cloud Optics for EDR, enabling all customers with an existing Intercept X4 server or better license, such as EDR Advanced, to gain access to the discovery features of Cloud Optics that we just looked at, as well as a limited version of our policy engine, enabling them to expand visibility of their assets into the public cloud platform so they have a better understanding of what surrounds those assets that they are protecting with EDR. And we offer it at no additional charge. Customers that wish to use this model are eligible for up to 110% of their current licensed server count in CloudOptics assets, and can simply run the onboarding as we've just described without any further enrollment steps required. And that gives me a nice segue to transition up from the foundations to talk about the host and code layer, because this is quite obviously the territory of our renowned Intercept X for Server solution, since, as we saw earlier, the shared responsibility model doesn't really cover workload security. Neither AWS nor Azure have any kind of endpoint security as a built-in feature on the platform, and both point to the use of third-party solutions to address this crucial part of the security chain. This then is an obvious shoe-in for Intercept X for Server, with its advanced anti-malware and anti-exploit technology, much like it is on-premise, by the way. So our truly futuristic technologies like CryptoGuard's behavioral anti-ransomware protection, Intercept X automated exploit detection, and even things like EDR, MTR, and server lockdown will all work in the cloud regardless of where they exist. And that's true not just from a feature perspective. We offer Intercept X for Server across the board on all major cloud platforms, as Intercept X is functionally platform independent. A Windows VM or a Linux VM is still a Windows VM or a Linux VM, regardless of where it runs and what hypervisor sits underneath it. And even from a deployment perspective, we support scripted deployments independent of the underlying platform. If the script provided can be run on the VM, we can install the agent. And it's this platform independence coupled with Sophos Central's centralized management that helps make migrations to the cloud a lot easier. Like I said, a workload is still a workload, so even if you move it to another environment, it will continue to enforce the security policy that you have set for it. In fact, all the features you know and love about Central from an endpoint perspective apply. Centralized logging, centralized reporting, a single pane of glass are all there to enable you to extend your estate's security management across the physical boundaries of your environment. And that even applies to advanced technologies like synchronized security. Regardless of where your workload exists, it will participate in the synchronized security synchronization, for lack of a better word, enabling coordinated defenses and automatic responses like you've been using on-premise for years, and just simply extend that into the cloud. We do, however, support some additional functionality when deploying on AWS and Azure through our connectors and additional deployment options. Starting with said additional deployment options, we support the use of CloudFormation user data scripting on AWS for the rollout of the agent, as well as a limited integration with Amazon's SSM, or Simple Systems Management. And on Azure, we support the use of VM extensions to push our agent to both newly deployed machines as part of their initial setup, as well as already deployed machines onto which you wish to install the agent later. And the connectors, for their part, enable a lot of additional integration features, such as support for dynamic licensing, in which new machines will automatically receive a license from the pool, and terminated machines automatically release their licenses back to said pool. They also enable, through metadata integration with Central, the ability to set policies specific to cloud workloads and autoscaling groups by examining metadata about the workload to determine if they are, for example, indeed part of an autoscaling group. We can even use this same metadata to detect any VMs in a connected platform account that aren't currently using a Sophos agent, so you have better visibility into the protection status of your cloud workloads, even if they aren't running a Sophos agent. And speaking of protecting workloads regardless of an agent, let's move up to the next layer in the model. Because now that we've got good visibility into our foundations, and have addressed the inherent security concerns in server workloads, let's examine how we can help protect the network. And for those of you who are familiar with our XG firewall feature set, this is another one of those no big surprises here situations, as XG addresses all of these items as part of its impressive feature set. So why would anyone deploy an XG firewall in the cloud? Well, as we've just seen in that shared responsibility diagram, both Amazon and Microsoft recommend running firewalls for additional filtering capabilities not offered by their platforms, like IDS, IPS, application control, web filtering, etc. It's also part of both of their recommended best practices. So in any case, you can basically refer to the documentation and show exactly where they recommend you apply additional security features. Another big reason to run XG in the cloud is that XG offers significantly more VPN options than the cloud platforms themselves, which generally only offer IPsec VPN. XG expands this with support for more client-friendly VPN options like SSL VPN, as well as backward compatibility options like PPTP and L2TP. It even enables the red SD-WAN functionalities we've been using on-premise in the cloud, making remote site connectivity a breeze compared to having to set up traditional IPsec VPNs between your remote sites. And beyond that, it addresses the need for content-level filtering in both inbound and outbound web traffic through the Web Application Firewall and Web Protection respectively, something that neither platform fully offers, yet is vital to businesses moving their desktops to the cloud at the breakneck pace we saw earlier. It's no wonder then that lots of cloud customers are looking for a solution like XG Firewall. It enables both better and easier management of their cloud edge security with much improved logging and reporting, as well as a significant expansion of the cloud native security features. And that ease of use also extends to the deployment of XG on these platforms, as we support cloud native deployment tools on both platforms to quickly and easily deploy into a customer environment. In just a matter of minutes, your XG is set up and ready to go. And in order to enable more cloud-native firewalling use cases, we support both pay-as-you-go and bring-your-own licensing schemes so customers can either pay per hour for the firewall performance and consumption they need, pay-as-you-go, or rein in their firewall costs to a set base point by opting for a term license using bring-your-own licensing. To give you an idea of just how easy it is and how quick you can roll out XG on these platforms, let's quickly jump into a Cloud Platform console to show the steps involved in deploying an XG firewall on both Azure and AWS. We find ourselves in the Azure Marketplace store page and we simply search for Sophos so that we can find the XG firewall offering. When we click on it, we're provided details about the offer as well as pricing. Once we're ready to proceed, we simply click on Get It Now, provide our credentials, and hit Continue. This then takes us to the deployment page, where we're presented with another overview, and by clicking on Create, we can start the deployment of the VM. This takes us to the Deployment Details page, where we select the subscription to deploy in and provide details like administrator password, network ranges, etc. It also allows us to select our preferred licensing type as mentioned previously, BYOL or PAYG, and the size of the VM in terms of CPU and RAM. And that's pretty much it. All that's left for us to do is accept the terms and conditions and start deployment. And we have a similar scenario on AWS. When we search for Sophos XG, it shows us the XG offers on Marketplace. The difference here being that Amazon lists pay-as-you-go and BYOL as individual offers. When we click on either offer, we're presented with an overview again, and by clicking on Continue to Subscribe, followed by clicking on Continue to Configuration, we can select in which AWS region we want to deploy and the method for deployment, CloudFormation in this case, and which version of XG we would like to set up. When we then click on Continue to Launch, this takes us to a page where we can select our desired action, which was launch from CloudFormation, and that's it. So now that we've looked at the deployment steps, let's examine the difference between PAYG and BYOL in a little bit more detail. As mentioned, in the pay-as-you-go scenario, you're charged on an hourly basis for the use of both the virtual machine as well as the software through the marketplace billing you have set up for either AWS or Azure. The license is simply provided through the marketplace as part of what you're consuming. That license, by the way, is always a virtual unlimited license, allowing you to size your VM to whatever specifications required for your workload. It also always includes the FullGuard feature bundle, enabling you to run any features needed for your setup with the notable absence of Sandstorm, which isn't part of that bundle. Now, as a Sophos partner, I can hear you think, hey, if the customer buys the license directly from Microsoft or Amazon, how do I make any margins on this? Well, the good news is that we've got you covered as part of the CSP program, which I'll get to later in the session. So don't worry about that. Now, in contrast to pay-as-you-go, we have the bring your own license model. This is pretty much a standard termed license for a virtual XG appliance that a customer applies to a VM that they have deployed through the mechanisms we've just discussed. Said license is acquired through a traditional Sophos partner. The benefits of this model are that it enables customers to license just the features they need instead of getting full guard, and be specific about the size of the VM in their base license selection. This then enables a potential for significant cost reduction over the more flexible but pricier pay-as-you-go model at the expense of the ability to resize your VM on the fly or build additional instances on demand without having to acquire a license prior to building out the instance. And with that, we have covered all the major layers of the shared responsibility model. So now we can map these solutions to these layers, and there's just one big remaining elephant in the room that you may have heard me mention throughout the presentation so far, but I haven't fully discussed in detail. And that is Sophos Central. And that would be an obvious mistake on my part, as Sophos Central, and by extension our synchronized security technology, is truly one of the things that sets us apart from any of our competitors in this space. As you may know, and you probably have seen this image pop up a bunch of times in our marketing material so far, Sophos Central is the heart of our product offerings, functioning both as central management, reporting, and logging facility, as well as the orchestrator for our synchronized security functionality that connects all of our products together. And this is relevant beyond the functionality I discussed back when we were talking about this in the Intercept X4 server bit, as Central effectively becomes the customer's one-stop shop for security management for their entire estate, regardless of where the managed resources actually exist. This works because Sophos Central is a hosted service. As long as your deployed Sophos agents or appliances can connect to the internet, they will connect to Central. There's no need to stand up any additional hardware or infrastructure to facilitate management or any of the features I just mentioned. And that is pretty cool and unique because now I can manage my entire estate from anywhere. And yes, that even includes workloads or virtual firewall appliances that are running in the cloud. They will simply show up in your personal central management console independent of the underlying infrastructure. And this point has gotten even more interesting now that, since the launch of V18, we have enabled comprehensive management of firewalls in Sophos Central as well, allowing customers to manage not just a single, but groups of firewalls through that same single interface, enabling them to quickly roll out baseline policies throughout their entire estate or subsections of their estate. For example, if I want to create a firewall rule that blocks a particular IP address on a single Azure firewall, I can do that through Central. If I want to roll it out to all of my firewalls in Azure, I can do that too through group management. If I want to roll it out to my firewalls in Azure, my firewalls in AWS, and some of my branch offices, it's all there through group management. You get the idea. It simplifies the management of firewalls and gives you a single pane of glass through which you can configure the configuration for all of your firewalls in just one place. And that also extends into reporting. One of the biggest headaches when it comes to managing security groups or other virtual firewalls in the cloud is keeping an eye on the overall security state of the combined environment. Yes, solutions like SIEMs exist to attempt to address this, but generally speaking, a SIEM is only as good as what you can extract from it yourself. This then is another area where Central shines, by not just enabling consolidated reporting for your agents, but now through firewall management, also for your entire firewall footprint, with reporting that spans across the boundaries of the physical and virtual deployments that you have in your entire environment, in your entire organization. So to recap, Sophos Cloud products are the same products you already know, love, use, and sell today. The difference is that they have been optimized to run in cloud environments. Now, as you can see, we offer a bunch of them across the board on all major platforms, such as Cloud Optics and Intercept X4 Server. XG Firewall is available on both AWS and Azure, and I should note that on AWS, we also offer our UTM firewall. And another thing I should note, since I mentioned SaaS at the start, we offer Sophos Email through Central for both O365 and G Suite customers looking for additional email security with that integrated visibility through Central. And that brings me to the final topic of this presentation, the Sophos CSP program. Now, this program was designed to help support partners that are specializing in public cloud to get access to relevant resources within Sophos, such as the security architect team that I myself am a part of. It also enables deal registration options as well as lead sharing, so they can work on qualified leads to make sure customers are guaranteed the best experience. Now, in order to become a CSP, all you need to do is enroll in the program through our website. Then, in order to get access to lead sharing and public cloud resources at Sophos, there are 2 certification levels attached to the program in which partners can, through self-study, show their familiarity with the material and the topics at hand and get recognized as either a professional or an expert with corresponding levels of benefit in the program. One of the important topics here, obviously, is the quarterly payout on marketplace billings. As we mentioned earlier, PAYG licensed environments do not require the customer to acquire a license through a partner in the traditional sense. This is possibly unfair to those partners that have spent a lot of time and effort assisting their customers in their public cloud projects. So in order to address that, we will provide professional and expert level CSP partners with a quarterly payout of marketplace revenue associated with the customers they have assisted under this program. All that we need from you to do is that you register the customer that is using a pay-as-you-go license with their account ID so that we can find them in our marketplace reporting and attribute the revenue to you as the partner of record. For more details on the CSP program, please check out our website under Partners and then go to Cloud Security for more details about the program and its benefits. And of course, since we just mentioned training, please know that all the relevant training for the topics we've just discussed today can be found in our partner portal, where you can find engineer and architect trainings on these topics, as well as on-demand technical trainings on various other topics. And with that, we've reached the end of this presentation. I hope you found it useful, and if you have any further questions, I would kindly invite you to reach out to globaltraining@sophos.com so we may address those questions in the best possible fashion. All that's left for me to do right now is thank you for your time and wish you a great rest of your day.